We're on lesson 1 of chapter 8, which we're going to graph linear equations. So first we're going to graph equations, then we're going to identify constant and variable change, then we'll solve a real-world problem. The first vocab word for this chapter is linear equation. A linear equation is an equation whose solutions fall on a line on the coordinate plane. The key words here is that they all fall on a line and that they're on the coordinate plane. So for example, if I have this equation with y equals m, which is the slope, times x plus b, which is the y-intercept, if I plug in 1 for x and get 2 as my answer for y, if I plug in 4 for x and get my answer for y as 4, if I plug in 7 for x and get 6 for my answer for y, these would all be part of a linear equation because they all fall on that same line. What determines the direction and position of a line is that slope and that y-intercept. The slope determines whether it's going to be going down or up or how steep that's going to be. And we'll talk about this in a later lesson, but it's going to be rise over run, the amount that it rises over the amount that it goes in left and right. The y-intercept tells you how high or low to have it. It tells you what y is when x here is at 0. But we'll get into this a lot more in later lessons. For now, let's just graph these equations. It says graph each equation to tell whether it is linear. So we have y equals 3x minus 4. So what we can do is we can plug in numbers for x, and we're going to get numbers for y. When we do that, we'll have coordinate points to put on this coordinate plane. So for x, I would like to plug in -2, -1, 0, 1, and 2. So what's y going to be whenever we plug those numbers in? Well, if we plug in -2 for x, for example, that would be 3 times -2, which is -6, minus 4, which is -10. When I plug in -1 for x, that's 3 times -1, which is -3, minus 4, which is -7. When 0 is plugged in for x, that becomes 0 minus 4, which is -4. When 1 is plugged in for x, that becomes 3. 3 minus 4 is -1. When we have 2 plugged in for x, 3 times 2 is 6, minus 4 is +2. So now that I've solved this, I have 5 different coordinate points. I have an x and a y that go together because they were both part of the equation. So when x is -2, y is -10, that's actually going to be off the grid here, but let's try making a guess right about there. When x is -1, y is -7. When x is 0, y is -4. When x is 1, y is -1. And when x is 2, y is +2. If you notice here, all these points that came from this equation follow a nice perfect straight line. And I can even graph that straight line by connecting all the dots and having it go through. This tells me that it is a linear equation because all the solutions go on a line. So we're going to say yes to it being linear. Now we have y equals -x squared. So I can plug these numbers in for x at -2, -1, 0, 1, and 2. I could do different numbers if I wanted to. I just choose to do these 5 because they're the simplest for me. So when I do that, what are my y values going to be? Well, I'm going to be doing the squaring first because that comes first in order of operations. Then I'm going to have the negative attached. So I have -2 squared, which makes +4. Then negative that would be -4. -1 squared would be +1, negative that would be -1. 0 squared would be 0, that just gives me 0. 1 squared gives me 1, the negative of that would give me -1. And then 2 squared would be 4, negative that would be -4. So let's plot these points out. I have -2 and -4. I have -1 and -1, 0 and 0, 1 and -1, and then 2 and -4. Now if you notice, these plots don't go on a straight line. So these are actually not going to be a linear equation as I try to draw this out. It's actually going to be a curved here. And what throws everything off is that exponent right here, the squared. Whenever you have a variable with an exponent, that's going to throw off your data. So we're going to say, no, this is not a linear equation. Now we need to identify constant and variable change. So it tells us to determine if the rates of change are constant or if they are variable. So we need to look at the rates of change. So we need to see how much it changes between each number. For this, we have a change of 1 for x. We have a change of 4 for y. So the ratio is 1 for x and 4 for y for the change. The next change is 2 for x, but it stays the same at 4 for y. I could tell right away that these are not the similar ratio. They are not changing at the same rate. This should have been an 8 difference here. This should have been a 12 here to make that the same. It even becomes more obvious as we move along. This is a 0 change compared to the 3, and then this is actually a negative 2 change compared to the positive 2. So we're going to say these are variable. As we look at this one, let's give ourselves some room. So the rate of change for x here is 1. Y is also 1. The rate of change for this was 3. Difference between these two is 3. Rate of change is 2. Here's a rate of change of 2. And then we have 1 and 1. So now I see the ratio, change of 3 here over a change of 3 down here. I see a change of 2 here over a change of 2 here. Well, 3 divided by 3 is 1. 2 divided by 2 is 1. So these are similar ratios. It's about as easy as it gets here because it's just a ratio of 1. So we are going to say these are constant, and that holds true with these ones as well. They all have to be the same if it's going to be a constant. You can't have one that is off, but since these are all on, that works. Now let's solve a real-world problem. It says a lift on a ski slope rises according to the equation A equals 130 times t plus 6250, where A is the altitude in feet and t is the number of minutes that a skier has been on the lift. 5 friends are on the lift. What is the altitude of each person if they have been on a ski lift for the times listed in the table? Draw a graph that represents the relationship between the time on the lift and the altitude. So it gave us the equation already actually, so it's A for altitude equals 130 times t for time plus 6250. Don't let these big numbers scare you. This is just like the equations we've been working with so far. This is that slope number that gets multiplied times the variable plus the constant, which is 6250. Now if we plug in the t, because it gives us the time here for t, we could find the altitude for each one of these friends. So if we plugged in this 4, for example, times 130, 130 times 4 plus 6250. 130 times 4 is 520 plus 6250 equals 6770. So my first coordinate point would be 4 for t and then 6770 for A. So if I plot that out, I would have 4 minutes. 6770 looks to be somewhere around here, pretty closer to the 800 than the 600 here. Now I have Diego. Diego spent 3 minutes on that lift. So Diego would be 130 times 3 plus the 6250. 130 times 3 is 390 plus 6250 would be 6640. So my new point would be 3 for t, what we plugged in, and then the 6640 for A. Here's 3 for t, 6640 is somewhere around here. Now Ted was on it for 2 minutes, so it's 130 times 2 plus 6250. 130 times 2 is 260 plus 6250 gives us an answer of 6510. So that would be a coordinate point of 2 and 6510. So that'd be right around here. Now we have 1.5. So we would do 130 times the 1.5. That'd be plus the 6250. 130 times 1.5 is 195 plus 6250 gives me 6445. So we'd have 1 1/2 6445, right about there. Then we have my solid for 1 minute. So that'd be 130 times 1 plus 6250. 130 plus 6250 would be 6380. That'd be a coordinate point of 1 and 6380. So 1 and 6380, right about there. If we were going to finish our graph with a line, we would try to make it fit perfectly. My drawing wasn't perfect, so this is going to be a little bit off, but you can tell it follows pretty much a linear slope. If my drawing was a little better, it would all fit exactly on that line.